This is in October, November 2022, variant 41 question. Figure 2.1 shows a thermometer that is calibrated to measure temperature in degrees Celsius. This is a thermometer. The thermometer makes use of the fact that the density of mercury changes with temperature. State two other properties of materials apart from the density of a liquid that can be used for measuring temperature. To answer this question, you need to know that a physical property that changes with temperature can be used to measure temperature. This question carries 2 marks. To score the 2 marks, you have to say any two of the 3 points here. So you can say either the volume of a gas at constant pressure, the resistance of a metal, or you can say the EMF of a thermocouple. Then part D, the thermometer is initially at 23 degrees Celsius. So you can see that here is 23 degrees Celsius. It is used to measure the temperature of an insulated beaker of water that is at 37.4 degrees Celsius. The bulb of the thermometer is inserted into the water and the water is stirred until the reading of the thermometer becomes steady. These are the information given to you regarding the mass of the water and the mass of the mercury in the thermometer, together with the specific capacity of water and the specific capacity for mercury. You're also given that the glass of the thermometer and the beaker containing the water can be considered to have negligible heat capacity. After reading the passage, you will focus on 2 keywords here, insulated. This shows that no heat energy is transferred between the system and the surrounding. Number 2, the glass of the thermometer and the beaker containing the water can be considered to have negligible heat capacity. So this will impact the heat energy either lost by the beaker or the heat energy gained by the glass of the thermometer. The heat energy gain and loss will be negligible because the specific capacity or the heat capacity is negligible. To answer this question, you need to draw a diagram to show the temperature of the water and the mercury so that you know the substance that gains heat energy and the substance that loses heat energy. So this is a diagram. This 37.4 degrees Celsius is the temperature of the water. And this is the temperature of the mercury inside the thermometer initially. And then this is a final temperature of the mercury and the water when the system reaches thermal equilibrium. So from here, we know that the initial temperature of the mercury is 23 degrees Celsius. The initial temperature of the water is 37.4 degrees Celsius. And then the final temperature, T, is to be calculated. So we know from this diagram how to calculate the temperature change for the water and also for the mercury based on the fact that the final temperature is T degrees Celsius. To solve this question, we have to set up an equation to solve the problem. The equation is that the heat energy lost by water is the heat energy gained by mercury. The heat energy gained by the beaker, the heat energy lost by the beaker, and the heat energy gained by the glass of the thermometer can be ignored because their specific capacity or the heat capacity is negligible. So this is 1 mark. This question carries 4 marks. This is 1 mark. And then we have to use QMC theta to calculate the heat energy absorbed by either the water, the heat energy lost by water, or the heat energy gained by mercury with the use of formula QMC theta. This will carry the 2nd mark. Then from the equation, this is the heat energy lost by water. This is a mass of water, 18.7. This is a specific capacity for water. And this is a temperature change for water. 37.4 minus T. And then this is a mass of mercury. This is a specific capacity for mercury. And this is a temperature change for mercury, T minus 23. So from there, we get 37.2 degrees Celsius as the answer. But to suggest one change that could be made to the design of the thermometers that would enable it to give a more accurate measurement of temperature. To do this question, you must know that the delta T must be larger. The change in temperature must be larger for the temperature to be measured more accurately. This question carries 1 mark, but 2 points are given here. So you can say one of the 2 points. Number 1 is use a liquid with a smaller specific capacity than mercury so that the temperature rise is larger. Or you can say use a smaller mass of mercury. The reasoning is here. The heat energy gained by mercury is Q, which is equal to mc times delta T. Q is a constant, so equals to mc times delta T. So the change in temperature equals to a constant divided by mc. So a smaller mass, as you can see from here, smaller mass of mercury or smaller C, smaller heat capacity, will make the delta T larger and the temperature can be measured more accurately. C part 1 and part 2 relates to the difference between temperature in degrees Celsius and temperature measured in Kelvin, which is the thermodynamic temperature. Explain why the thermometer in 2.1 does not provide a direct measurement of thermodynamic temperature. That's because this question carries 2 marks. This because the temperature measured in figure 2.1 depends on the properties of a real substance, and 0 degrees Celsius is not the absolute zero. Then for part 2, thermodynamic temperature T may be determined by the behavior of a type of substance for which T is proportional to the product of pressure and volume. State the name of this type of substance. The answer is ideal gas. Because for ideal gas, the PV is proportional to temperature. Facts that you must know to solve this question. Number 1, you must understand regions of equal temperature are in thermal equilibrium. Number 2, understand that the physical property that changes with temperature may be used to measure temperature. Number 3, understand that the scale of thermodynamic temperature does not depend on the property of a particular substance. Number 4, you must be able to perform calculation involving specific heat capacity.